piecewise functions are just a load of laughs because instead of doing one problem, you get like three, which I'm sure you love. So the way I want to approach this is first talk about what goes in these columns, right? This right here is your equation column. This over here is your condition column. So you put your equations on the left and the conditions related to those equations on the right. This f of x equals, remember, that means y equals. So we're talking about x and y equations. Now, let's start with the conditions first, because I can see very easily where these intervals lie. Okay, this one, for example, where is x? Well, it goes from -5 to x to -4. Okay, and then the next one, let's put some different colors on here. This guy in the middle, nope, orange is a bad idea. It's gonna be hard to see. This one in the middle is a quadratic function, and you can always double check, right? -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. All right, so that's a quadratic function, and it goes from -1 to 2. Okay, those are the bounds on that function. And then this last one over here, I'll just use red for this guy. That's a constant function. It's just a flat horizontal line. So its equation is going to be very simple, and its bounds go from +2 all the way to 4 with a less than or equal to. Okay, now let me clean this up a little bit. I want to talk about those inequalities right there. This is inequality notation. It's different from interval notation. And I want to point out something. See all these or equal to's? That's a coincidence. It's not always going to be that way, where all the or equal to's are on the right and all these signs are on the left. The reason that happens is because these dots on the right happens to be closed circles in this particular example that I was doing. I don't know why it turned out. That was just random. So we've got our intervals now, and I want to write the equations. Now the one on the right is the easiest, so I'm going to do that one first. It's just a constant, -6. The one in the middle is pretty easy too. We talked about that already. That's just x squared. The one on the left is going to be a little piece of work that we have to get through. Let me just clear some space here. This line that we have to draw gives students so much trouble because I think it's just been a while since you were in 8th grade. So we're going to use this standard slope-intercept equation right here. This is going to help us through it quite a bit. If only I knew what the slope and the intercept were, I could just plug it in and I'd be done, right? I'd have my equation. The slope is not too bad. If you remember what slope is, okay, that's m. That's really just rise over run. Well, what is rise for this guy? If you look at this, it's going down by 4, so that means -4. And what's the run? Well, that's this part. It's going over by 1. So the slope, m, is -4. Okay, that's actually pretty easy. The intercept is a bit of a challenge because if you follow this line down, it goes way off the screen there, and I don't know where that intercept is going to be. So instead we use a different method. We're going to plug in a point value. And I like this method a lot because it's easy. I'm going to plug in that point right there. I could have chosen any point on this line. Could have chosen that one, this one up here if I wanted. I could have chosen this thing in the middle right there. But I'm going to pick the point that's easy, -4, 2. So you plug in those values. -2 is the y value, and -4 is the x value. Oh, and we know m. Okay, m is also, that's a funny coincidence, m is also -4. So simplify this and we get this. -2 equals 16 plus b. And if we solve this down, we get -18 equals b. Okay, easy. Now we just write in mx plus b form. So m is -4, then we have our x, and then b is -18. So we're done with the top part. We've characterized all the equations in this piecewise function. And the last remaining thing to do is talk about the domain and range of this guy. This is not that bad, but I'm going to need a new picture because this one's getting a little crowded. So here's our graph again. And the technique I want to do, we're going to talk about domain. Technique I want to use here is something I like doing in class, which is imagining if I could take my hands these big hands on the side of this picture and squish everything down onto, I'm talking about range, excuse me. Make those hands on the top and bottom. Okay, you got these big things here, and we're going to squish everything down onto the x-axis. So I'll know what x values are in the equation, or in the graph. Well, think about what's going to happen. This circle right there is going to end up like this, and everything's going to get squished down over to here. Okay, got squished down onto the x-axis. And what happens over here? Well, that open circle stays there, and we've got this line that goes to +2. So everything got squished down like that. And this one also gets squished to there. The open circle on top of a closed dot, you have to ask yourself, this means it doesn't exist at that point. But this one means it does. So the result is it does exist. Okay, we're covered by this point right here. We don't care about that open dot. And then we go all the way to 4. Okay, that's what happens when you squish the entire function onto the x-axis. And it makes it very easy to read this as a number line. Now I can say my domain goes from -5 with a parentheses, because it's an open circle, to -4 with a bracket, because that's a closed dot. Union, because we have to skip over a whole bunch of stuff. This stuff we're skipping over. And then we get to -1. And we go all the way till 4. We do not stop at 2 to make another union symbol. We don't need to, because this is a continuous set of x values. There's no place on this line where we don't have an x value existing somewhere. Either it exists up here, or it exists down here, but it is somewhere. Okay, so there's your domain. Now we're going to do the range the same way. It's going to take two big hands and squish this thing down, except now, because it's the y values we're talking about, we're squishing it in towards the y-axis. Okay, so that's the image I want you to think about here. So what happens? Well, the quadratic is easy. That just gets squished like this. Okay, so we squish that thing down into the y-axis. And then we have this linear function on the left, and that comes cruising in here, and that squishes down also. Now, an open circle does not create an open circle. Remember what an open circle means. It means there's no y value right there. But there sure is one over here already. Okay, we've already got a y value there, so we don't care that we're missing a y value right here. That doesn't matter. But what happens is we get even more y values added. All these negative numbers going down as low as -2. Okay, so now I've got this whole area covered. Those are all y values that exist somewhere on the function. And then this one's kind of funny. When that squishes down, it just creates a little dot right here. Okay, so there's my range of values. And the way I would say this, using interval notation, is the following. I would start at the lowest one, -6. And we have to write it this way, -6 to -6, or the computer's going to scream at you. But honestly, if you had just said -6 inside brackets with no comma, -6, that would be fine, I think. But since it's computer homework, make sure you make the computer happy. So then we go to the next lowest value, that's -2, and we go all the way up to +4. And that's it. That's our range.